Hello and welcome to TDD and the Terminator, an introduction to test-driven development with me, Layla Porter. I'm a Microsoft MVP. I organise MK.net, my local .NET users group in my hometown of Milton Keynes in the UK. I'm a C# lover, and I'm also a developer evangelist at Twilio. You may be asking why I'm talking about TDD and the Terminator of all things. And to explain that, I want to take you back to my previous job. Well, maybe not my previous job, 2 jobs ago. This job was also for a communications platform, and I worked on a massive sort of complex system, all in MVC 4.6. And this was a huge integrated system with loads and loads of users and not a single unit test. So we relied heavily on our team of 6 testers. And it was before one release in particular that we had so many breaking changes and regression bugs that I had to spend 9 weeks fixing these bugs. And that destroyed a little bit of my soul. I knew there had to be a better way of doing this. So I started to look into unit testing, integration testing, and I came across test-driven development, which is where you start with your tests and then write your code. And I thought that would really suit the way I like to work. Now, when looking at TDD, I didn't actually know where to start. Reading didn't seem to be enough, and I watched videos of and all these people doing TDD, it just looked like magic, and I couldn't do it myself. So I needed to do something simple that I could relate to the real world. I'm a big fan of the Terminator movies, so I decided to write code, TDD, and build my own Terminator application. So that's what I'm going to share with you today, is how I built this application and taught myself test-driven development. So the first thing we're going to do is have a look at some TDD successes. So the different things with TDD, and these also apply to unit tests, I will say that, are number 1, acceptance criteria. With clearer requirements, you know actually what you need to do to write the tests and therefore the code to pass them. This really helps get that good relationship with your project manager or your stakeholders and make sure that they're thinking exactly what they want and that you're no longer just writing code against woolly requirements. So that's a really good thing in itself. Our next thing is focus. Many developers suffer from ADD, sort of attention deficit disorder, or shaving the yak. If you're not sure what shaving the yak is, go and have a Google of it. And so by writing only a single piece of functionality in a unit test, you can maintain focus. You're not tempted to go off and write a service that you need or go and write a new method somewhere else. You only write code for a single piece of functionality or a single criteria. So that's a really good respect for that. This leads you on to interfaces, which are kind of a coding contract. Now, if you have interfaces for everything, you've got this contract that you can give to your co-workers. They can get on with some code themselves. They're not dependent on you. You're not dependent on them. And you can just work asynchronously. So that's the next thing, asynchronous development. If you have a lot of interfaces, you can just work independently, as I said previously. This is really good in big teams and if you've got a lot of developers working on the same project. Now, you do get cleaner code. Because you're not juggling a million different requirements at once and you've got that focus and you have your contract, you can just write cleaner code with the bare minimum amount of code required to pass a test. And that's really important, that bare minimum bit of code. Now, when you've got cleaner code and you've got these contracts, that leads you on to safer refactoring. Now, why is refactoring safer when you've got unit tests in place? Well, if you have a regression, say you break something by adding a new feature, you know that your unit tests will start to fail. So you have that security net just to stop you building 9 weeks of regression tests. That means because you can refactor your code safer, you can now have fewer bugs. And that's a really win-win situation. You can just write lots more code without having to go and fix all the things that you may have broken previously. This does give you increasing returns. Many people will tell you that TDD will slow you down, but it doesn't. Maybe at first it will, but once you get going and you have that good foundation, you will get faster. Your team will get faster, and that's how you get that increasing returns. And you just won't have to spend so much time fixing bugs and going through regression cycles. And the final really good point is that it becomes a living documentation. It doesn't replace your documentation. However, you can send a new developer, for example, off to look at your unit tests, and they'll know exactly what the code should be doing. You can also use it as the starting point for your actual documentation. So all in all, there's a lot of good reasons to have unit tests, and many of those reasons for TDD. Back to the Terminator. Where do we start? What's the first thing that we need to do? And that brings us on to the process. So that very first step is gather the requirements. In this video, you can see that we're looking at a boy, and that boy happens to be John Connor. We've acquired our target, and we need to identify that target. And now we can extrapolate some requirements from that. So our requirements can now be scan subjects and determine if they require further investigation, and investigate subjects of interest and determine if they are the target. And if they are, you may want to terminate them. So let's take a look at that very first requirement. Scan subjects and determine if they require further investigation. We need to start with failing tests. And why do we start with failing tests? Well, if the failed test passes after you've written your code, then you know that you have fulfilled your acceptance criteria. It's generally a bit of a code smell if you start with a test and it passes immediately. That should give you a big warning, because you've probably not been doing TDD. So when you write tests after coding, you may be writing them to fit your code and not your requirements. So that's really key. And we don't want to be going into code and perhaps writing a test that fits that code and forgetting to check the requirements, because you may not be fulfilling those requirements. So this is a really key factor. So I happen to prefer the red-green refactor pattern. And what that is first of all, you write a failing test, as I mentioned previously. And then the key here is to write just enough code to get the test to pass. So just write only enough code to get that test to pass. So that keeps your focus and you're not going off in a million different directions. And then the final step is to refactor, and you repeat this process again and again. So I'm going to show you that now. So let's go on to some code. So over in my code, I have a basic .NET Core 2 application here, just built off one of the templates. And this is really basic, just a class library, and I have some stuff built in it already. I'm going on the basis that we've got some coding contracts with our co-workers, and we're going to be building out code that they may have already written. So let's go and have a look at what we've got. The first thing I have here is this interface called iSubject. Very simple. It's just got a subject name in it. I'll make that a little bit bigger. And I also have an implementation of this as well called subject. And you can see that implementing iSubject. The next thing I have is an interface called iSubject Analyzer, and that just has a single method down here called investigate further. So remember, our requirements were to investigate further. So we've brought that through. Our very nice colleague Bob has written this for us. This takes an iSubject called subject. Now I have my test written over here, or my test framework, I should say. I don't have any tests written as yet. Now, I happen to like using NUnit for my testing framework. However, you can use whatever you like, whether that's the Microsoft built-in testing framework or XUnit, which is very popular. I just happen to like NUnit. So you'll notice with any testing framework that it will have some decorators there. They're specific to the framework, but they're nothing really to worry about. They just tell your IDE that this is going to be a test, and it helps them make testing more discoverable by the IDE and the CLI. And what we have here is a setup. And what we need to do is assign our subject under test, abbreviated to SUT, to an actual instance of this so we can run some tests. Now you'll notice that I've got this set to iSubjectAnalyzer, which is an interface, and we can't do an implementation of an interface. So if I was to come down here and go SUT equals new iSubjectAnalyzer, the code's not going to be very happy because it can't do that. So we need to make an implementation of this. So that's going to be iSubjectAnalyzer. And you can see I don't actually have this. Is that just checking my spelling there? There we go. I'm just going to grab this, and we're actually going to make this right now. So if I come over here to the services directory, I'm going to add a new class, and that's called Subject Analyzer. So coming in here, the first thing we want to do is make this implement our interface iSubjectAnalyzer. Now this is going to get angry because we haven't actually implemented that correctly. So we haven't got that coding contract in place. So if I choose that implement missing members, you can see it's now got that method we had in our interface. Now, by default, when you implement an interface, it will come through with this throw not implemented exception, which is absolutely perfect for what we want to do. I'm not going to change anything on this code right now. So let's go back over to our tests, and you can see that this is now happy. We've got rid of that red squiggly because we've now got an actual implementation of this interface. Now I've just brought over our requirements here, and we're going to look at the scan subjects and see if they are of interest. So we're going to write our first test, and MUnit needs a decorator of test, and we're going to make this a public void because we don't want to return anything and we need the ID to discover it. And we're going to call this Terminator should. Now, I like to separate my names of tests by underscores into 3 distinct sections. You can do it however you like, just be consistent and descriptive. So in this one, our Terminator should determine to investigate woman further. Okay, because that's what we're going to test for. And I'll just open and close those brackets, and we've got our first test. So when you're writing a test, there's 3 things you need to do. The first one being arrange, you need to act, and you need to assert. So the first thing we're going to do is the act, which is going to be our var result equal to our subject under test, and then we're going to call that method. You can see that this method is actually expecting an iSubject. So that goes into our arrange. We're going to make a var subject equals new subject, and there it is. And we're actually going to instantiate that straight away, and that's going to be subject name equals woman. Now I am doing this on strings, which is really flaky, I know, but it suits our demonstration. So we could change this at a later date. So now we just need to pass this subject in. I'm going to just bring that up. And the final step is to assert. And to do that, I'm going to use fluent assertions. You can use whatever you like, but I quite like fluent assertions because they're very readable, as you will see. So we go result dot should, and we're going to say B, and we're going to go result dot should be true, because we want them to go and our Terminator to go and investigate a woman because she might be Sarah Connor. So let's run this now. I've got this play button over here and I can run my test. And what this will do, it will go off and discover the tests. And you can see straight away down here in the test explorer that we failed that initial test. And that's expected because we haven't written any code yet. So let's hop over to the subject analyzer and start to write some code. Now, I'm just going to pause here for a moment because I want you to look at this method. Terminator should determine to investigate further. And this needs to return true. So the bare minimum amount of code that we can write to make this test pass is as simple as return true. And that was a big aha moment for me when I started to learn test-driven development. So let's go back over to our test and run it. And you can see it's now passed. Now, the next thing we want to do is copy and paste this chunk of code, which is okay. And we want to see what happens if we don't want to go and investigate further. And I'm going to update this name here to be determined not to investigate anything further. Let's just take that woman out. And at the moment, we're on the same side as a T1000 Terminator. We're not interested in investigating one of those further because we're all working towards the same goal. So let's just make that a T1000. And down here, we need to update this to be false. So now we've got our second test method. We can run that. And I'm expecting this one to fail because we always start with a failing test, and it has. So let's go and write the bare minimum amount of code to get that to pass. I'm going to use an if statement here. You may be going, oh, you should use something else, but we're just going to keep this nice and simple for now. So if subject.subject name is equal to woman, we're going to return true. Otherwise, we're going to return false. Perfect. So let's go back over to our tests, run these again. You can see that's passed. And I'm actually going to run them all because we just edited the code a little bit more. And you can see that they have all passed. All right, let's go back over to our code now. We've got woman, true, false. You may be tempted just to go and start writing some code in here, but I'm going to stop you because we're going to come back and do our tests first. Now, I could copy and paste this entire chunk of code again, but that would be a lot of repetition and we could fill up this whole test class really quickly. So what I'm actually going to do is use a built-in test case, which allows us to run multiple test cases through a single test method. So in this one, I'm going to pass in my woman, and then we can pass that in as a parameter on this method. So that's going to be a string, and we're going to call that subject name. And then that final bit is to swap out this string here in our class initializer, and we've got that. Now, I want to also investigate if I see a boy, because it might be John Connor. So let's go and add that. We're going to change this over to boy. And we're just going to update the class name, the method name, sorry, to say investigate further. And if we go over to our test explorer, you can now see that we have multiple tests under here. We don't. We need to go and discover them all. So let me come up here and run all the tests. Let's see if we can run them all from up here. And it's not running my test because it's horrible. And let's come and click this button, run all. There we go. It's now discovered them. And it has failed. That's to be expected. We've got this first test case or the second test case failing because it's boy, and our code doesn't handle that. So if we come in here now, we can copy this and paste that, updating it to boy. And you're probably screaming at me to do this as a switch, but we'll get to that and we'll come back, rerun all of our tests. And you can see that everything has passed. So very quickly, we've gone through and created some tests and refactored to simplify it. And our code only does as much as it is required to do. So the first thing we want to do after we've written some code is refactor. And I'm going to go in and refactor the code we've just written. So let's have a look at what we've got. You can see I've now got a little bit more in my method. We're looking at woman, girl, man, and boy, and they should all return true. So what we're going to do is refactor that into that switch you were probably screaming at me to do earlier. It's not a fancy new C#8 switch. It's just a plain old one because we're eventually going to get rid of this. And you can see this is kind of what we've got at the moment, our tests with multiple test cases, and that all works. And then we also have our failing criteria, so when we shouldn't go and have a look, and that's fine. But what happens when your boss or your project manager comes up to you and says, requirement change? Let's have a look at what our requirement changes are this time. Now, if you have a look at this video, you can see that our Terminator has a port in his head open and something's happened to his memory chip. And basically, he now can learn. You'll also notice that he's not attacking John and Sarah Connor. So he's now changed to be their protector, which means that he'll probably want to investigate T1000s. He has also gained the ability to learn because they turned off the read-only switch on that chip. So now let's have a look at our new requirements. So the first one is to protect John and Sarah Connor from threats, and the second one is that ability to learn. We're going to focus on that first one, protect John and Sarah Connor from threats. Okay, so our code currently looks like this, and that Terminator should determine not to investigate further method currently works because anything other than woman, girl, man, and boy will return false, and that still works. But now we've changed that requirement. If we see a T1000, we're definitely going to want to go and investigate. So once we do that, we can see that our test will now fail. What do? Do we go in and start editing our code again? Do we go and change things? But this is where designing your application to be more robust can have profound effect on your code. And one way in which you can do this is by using design patterns. And my favorite design patterns are the solid principles. If you've looked at my Twitter profile, you'll have seen that I'm very interested in solid principles. I'm not going to regale you completely about all of the solid principles. Here they are, as you can see, all listed out. We're only interested in the first three, the sunny side, SOL. So that's the single responsibility, open close, and Liskov substitution. So let's have a look at those a little more closely. First up, we have the single responsibility principle. Every class or module in a program should have responsibility for just a single piece of that program's functionality. This allows for easier testing because you don't have multiple pieces of functionality within a single method. You know what it should do and what it should return. So that makes it very easy to test. Open-close principle. Software entities, classes, modules, functions, etc. should be open for extension but closed for modification. What does that even mean? Well, I'm going to try and show you a very simple implementation of the open-close principle in a moment. So we'll come back to that. And our final one is the Liskov substitution principle. Objects should be replaceable with instances of their subtypes without altering the correctness of that program. So we've already seen that in action with our iSubject analyzer earlier on in our code demo. Let's see it all in action. So let's go back over to our Terminator and we're going to refactor. On the left, we have our existing code, and I'm just going to refactor all of this code into a single test method, as we can see here on the right-hand side. I've now got multiple parameters in our test case. So if we have a look at the first one, we can see that we've got woman, which is a string, and true, which is a bool. And our test method is now expecting a string called subject name and a bool called outcome. And then we can see that we hand in the subject name to the initializer of our subject object, and that we hand outcome into the result. And you can see I've changed the result to just a result equals rather than using affluent assertions there. And you can see when I run the tests, everything passes just as it did previously. So let's go and look at our actual code implementation now. At the moment, this is what we've got. We have our investigate further method, and we also have the iSubject interface and the subject class that implements iSubject interface. And what we're going to add now is something called an iSubject rule. This has two methods in it. It's got the isMatch, which takes a subject, and of interest, both of which return a bool. On the left, you can see we've got our existing code, and on the right, we're going to do our first implementation of the iSubject rule. And this is woman rule. And this is based on the cases we have in our switch. And you can see in here, because in our switch, if we see a woman, it's going to return true. Our of interest method in the rule is going to return true also. The isMatch is just doing a little bit of string comparison on the subject name. Now, that is really, really flaky, as if we had woman, it would contain a man if we pass that in. So you wouldn't want to do this in production of your Terminator, but you could easily swap this code out for using an Azure Cognitive Services facial recognition API of some sort. So you could change this out to be much more robust, but we're just going to keep it on a nice string interpretation there. The second rule we've got is dog rule, and its of interest method is returning false, and the isMatch is going to again match on that string. So let's go on to the next slide, where we see our code investigate further has been rewritten to this code on the right. Now that looks massively more complicated, but don't worry, we're going to step through it. So if we have a look at the first thing we've got on the right-hand side, and alongside our subject rules, we can see that we have a list of iSubject rules called subject rules. Now, it's really important that this is a list of iSubject rules because it can take any implementation of subject rule in it. So that's really key here. The next thing you'll notice is that we have a default constructor for our subject analyzer. And we've instantiated our list of iSubject rules here. And the first thing we're going to do is start to add our rules. The first one being the isWoman rule. So we pass in a new instance of the isWoman rule into subject rules. And we do the same for isDog rule. We instantiate it and pass it into our subject rules. So we've got this collection of iSubject rules with 2 implementations of subject rule in there. Now, if we go down to our investigate further method, this has exactly the same signature because it's held by our coding contract. And if we go in there, the first thing we're going to do is use a little bit of link and iterate through our collection and find the first subject rule that returns true when we pass in a subject name. Now that might be woman, and if so, that would return the subject, the is woman rule, and if we passed in dog, it would return the is dog rule. And then the final step is to return the investigate further method, and that just returns the Boolean of interest. So you can see that here in the next slide, that we've got that just returning a simple Boolean. Now, if that private method was really complicated, you may be tempted to make it public and then update your interface. But if you're doing that, what about your colleague who's already written some code for this? You're going to break their code. So you really don't want to do that unless absolutely necessary. If you need to make a private method public in order to test it, then it's time to refactor. If you've implemented an interface and it has lots of non-implemented methods, that's a big code smell. So you want to start to look at refactoring that. And I'm just going to take you to the I in Solid, the interface segregation principle. Now, the ISP splits interfaces that are very large into smaller and more specific ones so that implementations will only have to know about the methods that are of interest to them. This one would be multiple smaller interfaces, and you can build them up in specific classes because a class can implement multiple interfaces. So use it. So if we go back to our subject rules, and if we run our tests, remember we haven't refactored our tests, they're all going to pass. Now, I did say that this was going to show you the open-close principle or an interpretation or example of it, and this is exactly what it does. This code is now open for extension, but closed for modification. So we can see now that every time we want to update the code with a new rule, all we have to do is add that to the subject rules collection. And you can see that we keep adding them here, and we're not modifying our code, we're just adding more rules to our subject rules collection. With good practices, code management becomes infinitely easier, and test-driven development can really help with that. If you take one thing away from this talk, I hope it's the following. If the simplest bit of code you need to write to get your test to pass is just simply true, then that's what you should write. Return true. And with that, thank you very much for watching. My name's Layla Porter, and you can reach out to me on any of the contact information you see before you. Thank you very much, and bye-bye.